objects or materials that may need to be grounded, removed from service, or rendered safe by other means. Bonding and grounding are typically used for any operation that transfers a flammable liquid from one vessel or container to another. This includes bulk loading and unloading of tank trucks and rail cars, charging of process equipment and mixing tanks, and transfer from large containers to smaller container. When preparing to load or unload a tank truck, first ensure the emergency brake has been set, wheels have been chocked, and all paperwork has been completed. Then make sure you attach the grounding cable to bare metal that is electrically continuous with the tank itself before you start to transfer any flammable liquid. Some loading and unloading stations are provided with grounding systems, which have a signal light to indicate that a safe grounding condition has been established. These devices are sometimes interlocked with a pump, so liquid will not flow unless there is a proper ground. It's also important to understand that when a flammable liquid is top-loaded into an above-ground storage tank, tank truck, or rail car, safety standards require fill pipes to extend to within 6 inches of the bottom of the tank. However, while this helps reduce static charge generation, in no way does it minimize your responsibility to assure a proper ground connection is made. In manufacturing operations, flammable liquids are generally transferred to process equipment or mixing tanks via conductive piping or hoses where bonding and grounding are designed into the system. However, in small batch operations or at other times, small quantities of flammable liquids may be transferred manually. And regardless of the size of the vessels or containers, the same general bonding and grounding principles must be followed. For example, when dispensing a flammable liquid from a 55-gallon drum to a smaller container, check to make sure the larger container is grounded. Then complete the path to ground by bonding the two containers together. There are other times when bonding and grounding are required. When mixing equipment is used with portable tanks or totes, always bond the metal portable tank or tote to the mixer and assure the mixer is grounded before starting the operation. Make sure you never attach a bonding clamp while a mixer is in operation. This could cause a spark, since a static charge may have already been built up. When spraying flammable liquids such as enclosed vessel cleaning, the spray nozzle needs to be well connected to the tank being cleaned. And of course, the equipment is required to be grounded. When powders from flexible intermediate bulk containers or bulk bags are handled, the static generation potential must be evaluated. Factors to be considered include the flammability rating of the powder, the bag designs or materials of construction, and the flammability of the nearby atmosphere. However, you should always take the safe route. If the bulk bag is groundable or conductive, make sure it is properly bonded and grounded. Let's take a minute to look more closely at some of the hardware used for bonding and grounding. In general, it should be highly conductive, mechanically rugged, and appropriate for the intended purpose. For example, flexible wire or cable is generally used for bonding. This minimizes the risk for it to kink and break. The ends of bonding and grounding wire should be equipped with specially designed clamps. There are 3 general types used: spring-operated plier clamps, screw-down C-clamps, and pipe clamps. Spring-operated plier clamps are used where grounding is necessary to safely accomplish a specific task and then are removed when the job is completed. The clamping force of spring-operated clamps must be strong enough to cause the contact points to bite into metal, even if the surface is painted or dirty. Notice how the sharp points dig into the metal to assure contact and a secure connection. Smaller spring-operated clamps are used on small containers and portable tanks or drums. Larger clamps are generally used at loading and unloading stations. When materials are transferred to or from a tank, clamps can be equipped with wire or chain releases on the handle to automatically disconnect should the driver move the vehicle without removing the clamp. Screw-down C-clamps are a good choice for making semi-permanent connections. such as when bonding drums to drum racks. Turning the screw forces the contact point into the metal through any rust or paint. Pipe clamps like this one are used to make permanent ground connections to a pipe. Alligator-type clamps are generally not recommended. Oftentimes they're not capable, or they quickly lose their capability of gripping the metal deeply enough to ensure a reliable ground and to prevent accidental disengagement. To be certain that a conductive path is maintained, all bonding and grounding equipment should be inspected by the operator to ensure continuity and to identify any sign of wear or damage. The operator should look for a buildup of dirt or material on the object, clamp or contact point, loose parts or connections, broken or frayed wire, damaged springs, dull contact points, or points that don't meet. Any of these deficiencies can interrupt the path to ground and result in the accumulation of static electricity. Make it a part of your routine to check all bonding and grounding equipment before each use. Report any deficiencies to your supervisor or team leader immediately. In addition, maintenance personnel should verify the integrity of the grounding system on a routine basis by taking measurements with an ohm meter appropriate for the application. The measured electrical resistance between the clamps of a bonding cable and ground should be less than 25 ohms. One other method we need to mention which is used to protect against the hazards of static electricity is inerting. Inerting means adding an inert gas such as nitrogen to a process vessel, ball mill, or mixing tank. Inerting doesn't prevent the generation or accumulation of static electricity, but prevents a fire or explosion by reducing the oxygen content to a level below that which will support combustion. Continuous automatic inerting systems monitor oxygen content and adjust the flow of inert gas to maintain a non-flammable environment within the vessel. Even though inerting may be used, it does not eliminate the need for proper bonding and grounding to further reduce the likelihood of a fire or explosion. By now you should be fully aware of what to do about static electricity in many industrial operations. But did you know that static electricity can also be a hazard in off-the-job situations? Dave is going to perform a familiar chore, one we do every day. He is going to pump some gasoline. Dave knows he should extinguish all smoking materials and shut off the engine. But he's not aware of the unseen danger static electricity can present. After Dave has started the flow of gas into the tank, he returns to the car to retrieve something from the glove compartment. As Dave's pants rub against the thousands of individual fibers in his car seat, he is accumulating a static charge on himself. So when he gets out of the car while still carrying the charge and reaches for the grounded gasoline nozzle, a spark suddenly occurs. Dave was lucky. It could have been worse, a whole lot worse. A static charge can also develop when walking on carpeting in the service station or even when removing an article of clothing. So when you pump gas, you should stay near the vehicle's fueling point. Do not re-enter your vehicle until you are done. And don't engage in any activities that could generate static electricity, like taking off a jacket or removing a sweater. Filling a portable metallic gasoline container can also present a static electricity hazard if it is done on a plastic truck liner or carpeted surface. Since the container is isolated from ground, it can become charged. So make sure that whenever filling your approved portable gasoline safety container, you place it on the ground, away from the vehicle or trailer. Touch the metal container with the gas dispenser nozzle before opening the lid. And keep the nozzle in contact with the container during filling to create a continuous path to ground. Static electricity, an unseen danger that can have deadly consequences. Make sure you understand how and why static electricity occurs, operations where static electricity can be generated, techniques for controlling the generation of static charges, including minimizing free fall distances, limiting flow velocities, and always using electrically continuous, well-maintained bonding and grounding systems to prevent the accumulation of static charges. Whether you're on the job or off the job, be aware that static electricity can be hiding and waiting to strike.